The 1/2 is a shrink, vertical shrink. Then the -5 is right 5. And then the 4 is up 4. Okay. The 1/2 is a fraction, so it's in between 0 and 1. That's the thing we struggle with the most. It's a fraction or a decimal. Okay, so it should be shrinking there. Okay, now sometimes they're going to ask you to compare it to a different equation, not just the parent function where everything starts at 0, 0. Okay, they're going to compare it to f of x at -x minus 3 squared plus 2 to g of x plus 1 squared. Describe the transformation from f of x to g of x. That's what they're asking you to do. Okay, so we need to have a starting spot. I always graph this on a number line. Makes it easier for me. So there's 0. I'm at -3, which is again the opposite. Okay, so I'm going to start at +3 here. So I'm going to start here. I'm going to start at 3, and then I'm going to move to what this is, 1. Okay, but again, it's the opposite. So I'm going to be at -1. Does that make sense? So I'm moving from 3 to -1. So how many spaces am I moving? 4. 1, 2, 3, 4. In which direction? To the left. So I move left 4. So that's one step for that. Okay. Then I'm going to look at the y values. Okay, so that's going to be on a number line that moves up and down. And here's 0 in the center. And it's just as it's given, so it's starting at 2. And I'm going to move to -6. So I start here. And I move to -6. So what did I move and where? Or, yes. Down 8. Does that make sense? So that's how I transformed. I went from left 4 and then down 8. So in your homework, they're going to have to compare two different equations. Okay, the next one. The next one's a little trickier because they give you an A value. Okay, in one of the A values, it's 2. It goes from 2 to 1. Okay, so 2, is that wide or narrow? Very good, narrow. It's a skinny graph. Okay. 1 is just normal, right? So describe from skinny to normal, what happened? If you're going to describe this to somebody, I went from skinny to normal, got wider, right? Okay, so that's going to be a shrink, right? From stretch to normal is a shrink. It's a vertical, let's see it spell better. It's a vertical shrink. Okay, then we're going to do from -4 to this right here is like x plus 0 squared. When it does the x squared, it's like x plus 0 squared. Okay, so I'm going from +4, 1, 2, 3, 4, that's my starting point, to 0. Okay, so we went to the left 4. So I have a vertical shrink, a left 4, and then what happens with the y value? I went from 2 to -5. So that's 2, and then 1, 2, 3, 4, 5 to -5. So that's down 7. Any questions over that? Yes. Can we wait till we're done or no? Okay. We're good? Okay, next. Now we're learning how to graph. Okay, graphing a parabola has some similarities to graphing a linear function, okay? Because just like when we have a linear function, we need to identify the y-intercept for a point to start with. We want to do that same thing. In this case, it's going to be the vertex, okay? I gave you the basic equation of a quadratic. Okay, that was f of x equals a times x minus h, the whole thing squared, plus k. The vertex is hk. The axis of symmetry I need an extra m in there. The axis of symmetry is just x equals h. Remember, axis of symmetry is where I can fold it in half and it'd be equal on both sides. So in their equation that we gave you, the vertex is right here, h and k. This is h, this is k. So the vertex is +1 and 4. Remember, you need to change the sign. Whenever it's in parentheses, okay, you need to change that sign. So it's +1, 4. And we're going to graph that. I'm going to go x is +1 and y is 4. That makes the axis of symmetry just x. Sorry, the axis of symmetry should be x equals that h value, which is 1. Okay, so I'm going to draw that line down the center. Any questions over that? Okay, the next thing we need to do is find the a value. Okay, the a value is always the number in front of the parentheses. What number is that? -1. So a's value is -1. Okay, so when you graphed a linear function, let's remember back, we would graph the y-intercept, and then we would use the slope to rise and run, right? We'd go up 1 over 2, up 1 over 2, okay? This is going to be a similar. We're going to have a pattern in which we're going to follow. It's not going to be a constant pattern. It's going to be a patterned rate of change. So like 1, 3, 5. That's our pattern rate of change. Parabolas rise at a rate of 1, 3, 5, 7, 9. It keeps going forever, like that pattern. Okay. The A value will affect how that pattern goes. Okay. So you're going to multiply the A value by 1, 3, 5. Okay. So our pattern is going to be A over 1, then 3 times A over 1, then 5 times A over 1. We've already told you that our A is -1. So we're going to plug in -1 here. Then we're going to do 3 times A. Then we're going to do 5 times A over 1. So the rate we're going to be using is -1 over 1, then -3 over 1, then -5 over 1. That's the pattern at which we're going to rise. Okay. On top, that means we're going to move down, in this case, down, but we're also going to move right and left. Okay, if it was positive, we would move up and right and left. Because we have symmetry with the axis of symmetry, you have to move the same left and right. So let's show what that looks like. You start your vertex. From my vertex, I'm going to go down 1 to the right 1. Down 1 to the left 1. My next points are going to be down 1, 2, 3, and then to the right 1. Down 1, 2, 3, and to the left 1. The next one is going to be 5. So I'm going to move down 1, 2, 3, 4, 5, and to the right 1. Down 1, 2, 3, 4, 5, and to the left 1. So my parabola looks like this. Connect all those dots. Any questions over that? Okay, let's try another one. Yes. Is this vertex a maximum or minimum point? It's a maximum point. Okay. Okay, let's graph another one. Same idea. On the back. Okay, we need to come up with a vertex. Good. The vertex, opposite sign, so it's a +2 and a -3. We need the axis of symmetry. It's just that x equal whatever the x value is. X equals 2. Any questions over that? Okay, we can all identify the vertex? Good. So we're going to graph that vertex at 2 and -3, which is right here. I'm also going to draw in the axis of symmetry at x equals 2. Our A value. What is our A value? Very good. The A value is the number here. Since there's nothing there, it's just A equals 1. Our patterned rate of change is A over 1, then 3A over 1, then 5A over 1. So we plug it in. It becomes 1 over 1, then 3 times 1 over 1, then 5 times 1 over 1. Okay, so that becomes, our first step is 1 over 1. So from this point, I move up 1 and then to the right 1, and up 1 to the left 1. So again, since this is all positive, it's going to be up and then right and left. The next one is 3 times 1, which is 3 and over 1. So I'm going to move up 1, 2, 3 and over 1. Up 1, 2, 3, and then to left 1. Okay. They're going to do 5 times 1, which is 5 over 1. So move up 1, 2, 3, 4, 5 and over 1. And then up 1, 2, 3, 4, 5 and over 1. And so this is my parabola. How are we doing? Good? Do you need me to do another one, or you guys think you got it? Okay, I'll do one more. And then I'll have you guys do the next one. Yassine, what is the vertex here?
-1.
Very good. -1, -4. Again, make sure you change that sign. That makes the axis of symmetry. X equals -1. So I'm going to go where x is -1 and y is -4, which is right here. My axis of symmetry is going to go right through the center there at -1. X equals -1. Travis, what's my A value? Very good. A equals 2. So my pattern is A over 1, 3A over 1, 5A over 1. We plug it in. We get 2 over 1 times 3 times 2. Over 1. Then 5 times 2 over 1. Since this is positive, I'm going to be moving up and down. So it's up, up and right and left. So from my vertex, I'm going to move up 2, 1, 2, and over 1. Up 1, 2, and over 1. The next step is 3 times 2, which is 6. So I'm going to move up 1, 2, 3, 4, 5, 6, and over 1. Up 1, 2, 3, 4, 5, 6, and to the left 1. Can I fit 10 on there? The next step will be 10. I can't move up 10. So I can just connect these dots. Any questions over that? We're all good? Okay. Try the next one. So again, our vertex here, since there's nothing in the with the x squared in parentheses, it's just 0. You can write it like this as well. Okay, so know that these two things are the same. So your vertex is at 0 and 5. So I go where x is 0 and y is 5, which is right up here. My axis of symmetry is right down the center at x equals 0. The a value is that number in front. Okay, its a is -2. So my pattern should be -2 over 1. So I'm going to go down 1, 2, and over 1. Down 1, 2, and go to the right, left 1. The next one should be 3 times -2, which is -6 over 1. So I'm going to go down 1, 2, 3, 4, 5, 6, and over 1. Down 1, 2, 3, 4, 5, 6, and over 1. And then this is my parabola. Since the a value is a negative, it should be facing down, and it should be skinnier. That makes sense? Okay, what's going to happen if I have a being 1/2? Okay. So same ideas, we're going to be looking for the vertex. Matthew, what's the vertex? Good. The vertex is the opposite, which is +1 and -3. And my axis of symmetry then would be x equals 1. So I graph where x is -1, sorry, where x is +1 and y is -3. Then my vertex, or my axis of symmetry, is right through the center. Okay. Lily, what's my a value? What? 0.5 or 1/2. I'm going to put 1/2 here because it says, but 0.5 is the same thing. Then my pattern is a over 1, 3a over 1, and 5a over 1. Since I have an a value of 1/2, it's a fraction, it should be a wider parabola. Okay, you might want to think about that as you're graphing it because you're going to make some common mistakes that'll make it skinnier. Okay, but it should be wider in this case. So we're going to plug it in. So I have 1/2 over 1. Then I have 3 times 1/2 over 1. Then 5 times 1/2 over 1. So that first step should just be up 1/2 and over 1. So I should move up 1/2 from this vertex and over 1. Up 1/2 and over 1. The next one is 3 times 1/2. What's half of 3? 1.5. So I should move up 1.5 or up 1.5 and over 1. So from this, here's 0.5 and then up 1 and over 1. Here's 1/2, then a whole, and over 1. Does that make sense? The next step is going to be, what's half of 5? 2.5. Okay, if you don't know, use your calculator. 1/2 times 5. Then go up 2, 1, 2.5, and over 1. Up 1, 2.5 in between, and over 1. So this is 2.5. And so this should be my parabola. Is it wider? Yes, it's slightly wider. Any questions over that? We're good? Okay. Now we're going to talk about soccer. You know what? Let's do one of these first, and then we'll go back to the soccer because I think that will help. Okay, in this one, I'm going to give you guys, we're going to do this one, the graph, and I'm going to ask you to write the equation. So I have f of x equals a times x minus h, the whole thing squared, plus k. That's the equation of a quadratic or of a parabola in vertex form. So step 1 is to find the vertex. Good. So my vertex is the lowest point in this case. It's at 2 for x and -5 for y. Step 2 is to find the a value. Okay. Remember that very first step is a over 1. So you move up a and right and left 1. So if I go to the right 1, how far up did I have to move to get to my next point? 2. So my a value is going to be that first step, which is 2. Does that make sense? So the a value is 2. I know it's kind of hard to see on your graph because the graph is really little, but you do have to move 1 step to the right, and then how far up did you move? Does that make sense? Okay, now you just plug it in. So we have f of x equals 2 times x minus, I plug 2 in, it becomes negative, squared, and then minus 5. So that's the equation of that graph. Any questions over that? Okay, now we're gonna go soccer. So I just told you all about my weekend. We went and watched 5 games. Okay. Now we're gonna talk about Deshaun and Chris. Okay. Any type of ball, when it's kicked or thrown, is going to follow a path of a quadratic function. It's going to have a curve. When you're shooting a basketball, it has a curve. Even when you're pitching, there's a slight curve downward towards it. Okay, when you're kicking a field goal, passing a football, it's all going to have kind of a parabolic curve to it. We can determine if the soccer ball is going to be blocked or if it's going to get into the net based on the path of this ball's quadratic function. Okay, they've given us some key ideas. So Deshaun and Chris are playing soccer. Chris takes a shot on goal. Deshaun is 3 feet in front of the goal. So here are goals at 25. 3 feet in front is at 22. Okay. And can reach the top of the 8-foot goal when standing directly beneath it. Okay, so how tall is he when he reaches his hand up? 8 feet. He's 8 feet high. Okay. When standing directly beneath it, can he block the shot from his current position without moving or jumping? So if he just reaches his hands up, can he block the shot? Okay. In order to do this, we need to be able to write our function in an equation. Okay, I need to write an equation so I can predict. They didn't give me much. They did give me my vertex, though. So the vertex is 16 and 11. FYI, you're going to have to write small because we're going to have to do a lot of math here. I should have given you guys more room. I did not, though. I apologize for that. So we plug this in. F of x equals. I do not have an a value either. But I do have x minus 16 squared plus 11. Okay. To find the a value, we talked about rising and running. But based on my graph, they didn't give me a lot to show how far I moved down and then to the right or left with it. Because it doesn't give me very many vertical numbers there. Okay, so I can't just count. Okay. They did, however, give me this extra point, 2 and 1.2. So if I plug in 2 and 1.2 into my equation, I can solve for a. So that's what we're going to do. Plug in 2 and 1.2 in for x and f of x. So now we're going to replace the x and the f of x with 2 and 1.2. So I have 1.2 is my f of x, and it equals my a value times my x value now is going to be the 2. Minus the 16 squared plus 11. Okay. Okay, so now I'm going to just solve for A. So we're just going to do the math to solve for A. So order of operation tells me to do this first. I'm going to get 1.2 equals A times 2 minus 16 is negative 14 squared plus 11. Then I'm going to square the 14. I'm going to get 1.2 is A times, what's 14 squared? 196, I think, plus 11. Okay, I'm going to subtract the 11 from both sides. 1.2 minus 11 is negative 9.8. I'm just going to switch this to 196A. It's the same thing. I just switched the order because it's easier to look at. Finally, I'm going to divide by 196. If I plug that into my calculator, I'm going to get A equals negative 0.05. Okay, so now we're going to plug it all back in together. Okay. So I've got my equation now. I have f of x equals, I have an A value of negative 0.05 times x minus 16 squared plus 11. Okay, so I need my equation before I can do anything else. Okay, so I have my equation down. Now I can find out. What am I trying to find out at this point? Let's go back to the original question. Okay, from where he's standing, can he block the shot? Okay, so I want to know how high the ball is going to be at 22 feet. Okay. So now we're going to plug in x equals 22. So we're going to plug in 22 for x to see how high he has to reach. To find the y value. Come on. Or in this case, the f of x value. Okay, so f of x equals 0.05, and it's negative, times x. We're replacing the x now. With 22. Minus 16 squared plus 11. Okay, let's do the math. Okay, 22 minus 16. Oh, that's interesting. That's really big. Want smaller. 22 minus 16 is what? 6? 1/6 squared. It's like a rainbow, glitter rainbow. Okay, 6 squared is 36. Okay, 36 times negative 0.05. Okay, that gives me negative 1.8 plus 11. So we have f of x. It equals, is that 9.2? 9.2 feet. Okay, so in the end, can he reach 9.2 feet without jumping or moving? No, he can only reach 8 feet. So he cannot block the ball. He cannot block the shot. And then all this is my answer. Yes. Yes. You'll have a problem, well, you'll have to, it'll walk you through the steps. Write the equation first, then plug it in, then answer it. Yes. Yes. I would not show you an example if it wasn't going to be in your homework. Okay? So do your best, do the right